In the past month, our minds have been pushed to great extent to develop our how might we question in a unique and life-changing way. Our initial thought was to stimulate an organ system in the human body, but instead we took a different route based on the following idea. What if trees grew taller?
The real question is, why can't trees grow infinitely tall? But as for what's stunting the growth, it all comes down to capillary action.
In short, capillary action is the physics of moving water through porous materials, in this case through tree roots. However, as it starts to grow taller, the gravitational pull becomes too strong, and it starts to limit the height at which the water can travel.
Ultimately, gravity stops the tree from growing unbelievably tall. But what if the tree was in space without any gravity?
Well, that's exactly what we'll be testing. Our design shown on the screen here is a system of graduated tubes, acting as roots. Now we filled up from the bottom with water. We'll be simulating capillary action in space to see if there's a difference from the way it usually works on Earth.
Generally, the height at which the water rises in the tubes is limited on account of the gravitational force. But as we know very well, gravity is reduced in space, therefore making us believe that water will rise higher in the tubes.
Bringing us to conclude that trees can grow larger and taller in microgravity. From past experiments, we know that seeds sent to and from space are more resilient as they can withstand droughts and grow faster. So this can lead to an agriculture space industry.
In the long run, our experiment can help with two things. One, it is especially important to help combat climate change. And two, it'll give us more insight on agriculture as we prepare to eventually colonize new planets like Mars. In conclusion, our design tests the behavior of capillary action in space will provide knowledge to improve human life.